Hey guys, I am Vibhor. So my final project for CS50 course is AES 256. Right now I live in Hyderabad, India. Let's go through my project. So uh, first something about AES. So AES is one of the modern advanced symmetric cipher. It is a block cipher as it operates on block by block of input. We also read about symmetric cipher in our CS50 course, like Caesar cipher and beginner cipher, but they are too weak. Breaking the cipher encrypted from those cipher is pretty easy with the as we have the state of art computing facility available to us. Uh, so in symmetric cipher means same key should be present on both the side. So the party which is gonna to be encrypt the input should have the same key as the party which is gonna to decrypt the encrypted input on the other side have. So so they should be agree beforehand on one key before this encryption decryption started. So AES can be of many types like AES 128, AES 196, AES 256, where this 128, 196, 256 are key sizes, and this also means the block size. So if we are talking about AES 128, then the key size will be 128, and the block size on which this AES will be performed will be 128 only. So AES is pretty famous and very strong encryption algorithm which is being used worldwide in many applications. So let's talk about the basic of let's talk about the technical terms for this AES. So AES contains n number of rounds for different bit encryption schemes, such as for AES 128 we have 10 cycles, and for AES 192 we have 12 cycles, and for the AES 256 we have 14 cycles. So let me give you very high level description of algorithm, because providing very fine detail of this algorithm is not going to help anyone. And okay, let's go through the description of this algorithm. So the first the each round include two main one of the each round include two sub rounds. So the first round is key expansion, where uh, here for n number of rounds we create n keys from the initial key, as these n rounds key will be used in each subsequent round. So now uh, for each round we perform four things. The first thing is add round key. Here we we XOR the input block with the one of the expanded key. Then the second part is sub bytes. Here for each byte is replaced with another according to some lookup table. Third is the shift row. Here we shift rows cyclically. And the fourth is mix columns. Here this is a kind of a matrix multiplication with some field. It operates on column by column. So these are the these four steps uh, is performed repetitively for this 14 rounds for this 256 bit key, and in each round we perform this repeatedly. So in the end of the 14th round we get the encrypted output, but and we just perform inverse in the inverse to decrypt the encrypted input with the same key. So let's go through the code, and then I will show you a live demo of my code. So this is the S box. This is the thing. This is the lookup table we were talking about. So you can see these are just the numbers hard coded. So uh, these are all. This is the lookup table for inverse for decryption. And let's go through the main. So this is the add round key function. So in here we are just zoring the uh, we are just zoring the uh, key with input block. Okay, so the second is byte sub. Here we are substituting bytes from the lookup table. So this is the S box is the lookup table, and based on the current input we are substituting bytes from the S box, that lookup table. Then comes the third, that is the shift row. Then comes the second, it is the shift row. So here we are just shifting the row. So based on some predefined predefined so based on some predefined uh, algorithm, we shift the rows one by one. So here we are shifting the rows. And the last one is mix column. So here based on some another static field, we multiply columns of that matrix with those fields, with those columns. So here we are performing that. So and the last and this is a key expansion function. Here we are expanding the key from the initial key. From this initial key we are generating n round keys. So for the each round we use that distinct key. So I'm not going in much detail of how these functions work, because that is in all alone a separate module. So this is the high level idea of the code. So let's go through how it is working. So let's go to the live demo of this AES 256. So you can see I put uh, in the D drive, I put this key. So my key is like A B B C D E F G G E F 0 1 1 2 3 kind of a key. So and my input is this one 0 0 1 1 2 2 3 3 4 5. Remember, this is the hexadecimal notation for the key. So let's start with the I am deleting this input and input, and these are created uh, beforehand when I was testing my code. So let's go. So let's run this. I need to change the configuration of my code. So E is for the encryption, and this is the name of my key file, and this is the E is for the encryption, key is for the key file, and this is for the input is for my input.txt file. So I will do this run, and you will see something happens in the console, and this is the last encrypted output. So you can see in the same D drive there is an input.enc. So when we open this with the notepad, so we can see this is the same encrypted output that was shown here. Okay, so let's uh, let's go quickly and create decrypt this encrypted output. So I will go again to this run configuration, and now I will use D key will be same, as this is a symmetric key algorithm. So same key should be present on the both side. So D is for decryption, key is for key file, and now we will use input.enc, which contains the encrypted output, encrypted text as an input for the decryption algorithm. So decryption algorithm, AES decryption is same as the AES encryption, just everything is happening in the reverse order. For the same number of rounds are there, the same sub steps are present. So let's go and run this. So you can see the output is the same, the output file is the same. So the output that is the plain text that we had beforehand is the same as we had in the input. And we can also be double sure, as this file is just created when we ran the decryption, so it also contains the same input. So we retrieved the same input from the encrypted plain text. So this is all about my project AES 256. So AES 250 is one of the strongest symmetric key algorithm, and that's all, folks. uh, I enjoyed a lot during my CS50 course. Hope you also enjoyed well.